So we now have an equation of the form 0 equals ax squared plus bx plus c, where a is negative 0.05, b is 0.224, c is negative 0.595. And so that means that the x value that will solve this equation, that will make the right-hand side 0, is the quadratic formula. So I'm going to now enter that in. I will just go ahead and do it just so we get a little bit of practice seeing it. So it would be negative b, which is negative 0.224. I'll do the minus first. The square root of b squared, so that's 0.224 squared, minus 4 times a, which is negative 0.05, times c, which is negative 0.595. I'm going to close that square root. I'm going to close that numerator, and I'm going to divide by parenthesis 2 times a, which is negative 0.05. And I get one solution, which is, now in this case I hit enter, and I get a non-real answer. So what does that mean? Well, if we go back and look at the equation, or the quadratic formula that we entered in, we have b squared minus 4 times a negative number times a negative number, which is positive, negative. Well, it must be the case that I have a negative under the square root. So what does that tell me? Well, it doesn't matter whether I do 0.224 minus or 0.224 plus. The fact is I'm taking the square root of a negative, and my calculator is telling me that it's a non-real answer. So I can't take the square root of a negative and expect a realistic answer. So in this case, I would just say x does not exist. This value of x that satisfies this equation, not possible, doesn't work. So what does that tell me about the original problem? Well, the original problem was asking me to find the year if they were ever going to be the same. And I find that there's no x for which these two equations will ever be the same, which must mean that this one is decreasing at a constant rate, but this one picks up and goes down a lot faster, in which case I notice that the 15-year rates end up dropping faster than the 30-year rates, and in such a way that they actually never see a common point. So I would have to say that no, these two mortgage rates will never be the same. And if you are into buying houses at all, then you would know that this makes sense, because rarely is a 15-year rate below or above a 30-year rate. 30-year rate's usually higher than a 15-year rate. And that's I'll leave that up to a finance class for you to figure out why. Finally, I want to do some spotting some potential pitfalls before you start. So before you start getting into solving equations, ask yourself, okay, what is this asking me to find? So in this situation, I have So we have two linear functions, and the first thing that we notice about is that they both have constant rates of change, and at that, if you look at the rates of change, this one starts at negative 10, increases by 3.7 for each increase in x, 1 unit increase. This one starts at 4 and has a increase of 3.7 for every 1 unit of x. So if you graph these, well, one would begin down here and go up at this rate, let's just say. But then this one would start here and go up at the exact same rate. So if two things increase, one starts higher, one starts lower, and they increase by the same, both increase by the same amount, can they ever be equal to each other? Well, the answer should be no, they can't. And in fact, if you were to try to isolate x and subtracted 3.7x from both sides, here's where the weird part would take place. Both sides, they'd cancel out, and you'd be left with negative 10 equals 4. Which we know is a false statement, and that is an indicator that the math isn't working out, that that's an impossible equation to solve. Check out this one here. Well, let's think about what this looks like first before I try to solve it. So this one starts at 10, and it has a positive coefficient in front of the x squared. The initial rate of change is 0, because we have technically plus 0x here, and technically this is a plus 0x here too, but it's going to continue to increase since the change in the rate of change is positive. And this one starts at negative 10, and it has a change in the rate of change which is negative, so it's going to look like this. Now if we tried to solve it, we should get a non-real answer and therefore cannot be solved.